What's going on? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example, another one dealing with sequences, series. So here we have to evaluate this sum here. So notice that this sum, it's going to start at a counter I is equal to 7, and then we're going to keep going up by ones on the counter until we get to an I value of 100. So what I like to do with this kind of question is write out what the first few terms are going to be with the first few counters. So the first counter, right, we're starting with an I value of 7. Well, when I is going to be 7, what's going to be this term here? So we plug in that I value of 7 here, 5 times 7, 35, minus 2, that would give us 33, like that. Right, so that's the first term, and then we go to the next counter, which is 8. If we plug in 8 here, 5 times 8 minus 2, that gives us 38, right? 40 minus 2. Then let's go to an I value of 9, or a counter of 9. 5 times 9, 45 minus 2 gives us 43. And hopefully at this point, you are seeing what the pattern is. Right? And we could keep going. And basically, this is going to keep going until we get to an I value of 100, right? And that's going to be the last one. And let's actually get the last term here. So if we plug in 100, 5 times 100, 500 minus 2, that's going to give us 498. So that's going to be the last term. Now, what this sigma means here is that you're adding all these terms, right? So we could rewrite this as like 33 plus 38 plus 43 plus, etc., 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 all the way to that last term of 498. And hopefully at this point you're seeing that this here is going to be an arithmetic series, right? Because notice that each term is going up by 5s, right? So we know that the first term of this arithmetic series is going to be 33. And then the common difference is 5, right? Each term, we keep adding 5 to it. That's the pattern that we got. Now, question is, how many terms are there going to be, right? In order to find the sum, in order to use the arithmetic series formula, we have the first term, we have the difference. We also need to know the number of terms. Well, couple of ways we could do this. We know what the last term is, so we could plug that into the sequence formula, which is basically an equals a1 plus d bracket n minus 1, right? So we'd have 498 is equal to 33 plus 5 bracket n minus 1, and then we could solve for n. And when you do that algebra, you'd get an n value of 94, meaning that there's going to be 94 of those terms. So that's one way to get it. You could also, right, so this is when I is equal to 7. This is when I is equal to 8. You could just see, okay, what's the pattern here going to be? And this is going to be when I is 100, right? So notice that, for example, here, if I relate the term numbers, so notice that the 43 is the third term. So if I take 9 minus 7, that's going to give me 2. But because that I equals 7 is represented by the 33, we would add 1 to the difference in order to get the term number, right? Because this is the third term. This is the first term, second term, etc., etc., right? So we did 9 minus 7, which is 2, and then we add 1 in order to get that third term. Well, if we use that pattern here as well, we could do 100 minus 7, which gives us 93, and then add 1 in order to realize that the 498 is the 94th term, right? So whether you do it like that, or whether you take this algebraic approach, knowing what the last term is in the series, and then using the sequence formula to see what's the term number going to be, what's that n going to be, which is going to be 94. Either way, there's 94 terms in this arithmetic series. And to get the sum, right, of an arithmetic series, there's actually two formulas, and we could actually use both formulas in this case. So the first formula is n over 2, a1 plus an, the last term of the series which we have, which is the 498. Or you could use the other formula, n over 2, 2a plus d bracket n minus 1. right? So either of these formulas work with what we're given, right? Usually only one of them is better to use, but in this case, it doesn't really matter. You would get the same solution. So the first term is 33. Last term of this series is 498, right? So you could do the algebra there. Or we can use this formula, which would be 94 over 2, 2 times 33, bracket 5, bracket 94 minus 1. And close the two brackets like that. And then when you do the algebra on both of these, final answer for both is going to be 24,957. So that is the answer to this question. That's going to be the sum of this series, right? So again, if I get something like this in the sigma notation, I like to write out the first few terms, see what the pattern is, right? We can see what the first term is, common differences. And then I also wrote out the last term when I plugged in the 100, which was the 498. And then from there, you have to figure out how many terms there are. So whether that's taking the difference between the first counter and the last counter and then adding 1, or manually solving it with the sequence formula, solving that n value of 94. Then once you have all that information, plug it into the series formula, and you're good to go. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.